All right. So in chapter 3, what we want to do is look at a new type of number. So what happens is, obviously, you can have positive numbers minus like a positive number, and that's not really an issue. Yeah, so you would just do 12 minus 8, and you just get 4. Now, what happens is, what happens if you have 12 and you take away like 18 or something, though? Okay, well, what happens? Yeah, what happens is, if you have like $12 in the bank and then you spend 18, you're going negative, right? And so this one's going to go back. In fact, it's going to take you back to -6. So what happened is, our number system like evolved over time, and like initially in some of the earliest counting systems, they didn't even have like a number 0, because like they didn't. Why do you need a number 0? Because you're not going to count something that's not there. Okay, well, so then 0 got added. Then when you start working with subtraction, if you introduce the idea of an operation that you can subtract two numbers from each other, well, then you can run into this problem where, okay, well, what happens when you try to subtract a number that's bigger than another number? And so then the negative numbers had to be added into the number system. Okay, so that's how negative numbers sort of originated, is once they figured out subtraction, then they realized, okay, well, you could go less than 0 feasibly, And typically, we think about the numbers on a number line. Now, I'm sure you've probably seen a number line before, okay? And the idea is, it's sort of like this infinitely long line, and we think of the center being a 0, right? And then you can go positive numbers, negative numbers. So positive 4 would be 1, 2, 3, 4. So this would be 4, and then down to 1, 2, 3, 4, 5. This would be -6. So that'd be like two numbers on the line. Okay, and you can go both ways. And mostly where you run into negative numbers, they're not that common, but they occur in a few places. So where's at least one place that you've encountered or seen negative numbers? What's that? Temperatures. Temperatures can go negative. That's probably one of the main places you've ever seen negative numbers. And then what else? Because there's not a lot of places you can actually have negative numbers, right? It's not like you can have like a negative number of people or like a negative number of books or whatever. Yeah.
Bank account.
Yeah, money is the other place. So the most common place that we've encountered negative values is probably actually in money. The idea of owing money or having a negative balance, that's something that you probably have some understanding of. So that's probably the main application of negative numbers. But negative numbers are, they have a lot of other applications in math as well. Anyways, okay, so when we're talking about negative and positive numbers, then if you get into like inequalities with negative numbers, so for example, okay, so we know that, say, 2 is less than 5, right? That's true. Now, what about, how does -2 compare to -5? -2 is bigger than -5. Is that true?
Mm-hmm.
Yeah, why? It is because it's closer to 0, but it has to do with what inequalities measure is they measure where you are on the number line, right? And so if 2 is here and 5 is there, right, 2 is to the left of 5, but on the flip side of the numbers, -2 is here, -5 is there, right? And so you read the number line from left to right, in terms of small to big. And so then -2 is actually bigger than -5. You can think of it as like in terms of money, right? You'd rather be here than there. Okay. Technically, even though you have no money, you have more money. You have less not money. Whatever, you know what I'm saying. Okay? All right. Does that make sense? What one operation though that's sometimes we're not really necessarily interested in the sign, but just the magnitude. So there is an operator that we use in math sometimes, which is called the absolute value of a number. And so absolute values, so I'll give you an example. They usually are with like bars. So like let's say we had the number -2, but we use these 2 bars right here around them. And the bars are telling us to take the absolute value. All right. Well, what does it mean to take the absolute value? Oops, there should be a B there. Oh, no, there was a B there. Whatever. Absolute value is what it's supposed to say. What does it mean? Anybody familiar with absolute value? What's it tell you to do? It's going to turn that number positive. Why is it going to turn that number positive? Anybody know? Because that's the rule. Because it is the rule. But why? Does anybody know? The absolute value of -2 is in fact +2. That's true. The reason is that the absolute value, it's actually a measurement of a distance. So what the absolute value does is it measures the distance from a number to 0. That's what it's actually measuring, is a distance. And so, because of that, because it's a distance, then the absolute value is always positive. Because we never think about distance as in, we never think of like a negative distance value. You can't travel a negative distance, right? It doesn't matter which direction you, it's like your car. It's not like when you drive to school, you get to undo all your miles when you drive home because you're going backwards, right? You still have to count the distance. So distance is always positive. So what the absolute value essentially does is it takes negative numbers and it turns them positive, because on the number line, how far away is it if you have to walk from -2 back to 0? How far are you going to have to walk? 2, +2. So that's what the absolute value does. And what about positive numbers? So like if we had to do, what about the absolute value of 5? What's it going to do? What do you think? Well, how far do you have to walk from 5 back to 0? 5. It's always positive, so it just leaves positive numbers positive. Okay. So that's the moral of the story. The moral of the story is the absolute value just turns everything positive. If it's negative, make it positive. If it's positive, leave it positive. But the reason why is because it's a measure of distance. All right. Anything else? Oh, one other thing about that. So if you do encounter absolute values inside of order of operation, so the absolute value is on the same level as parentheses. Okay. So like as an example, let's say that I had, 5 minus 2 times the absolute value of, I don't know, like 3 minus 6 or something. Actually, I don't want that. I'll make that a plus. I'll make our lives easier here for a second. But so if I encounter the absolute value within an expression, then what do you say? So where should we go first then? See, since they're on the level of parentheses, that puts them at the top. And so we need to complete this first. We need to go inside the parentheses and simplify that. So the 5 plus 2 we're going to leave alone. And then 3 minus 6, what does that come out to be? So this is one of those scenarios where we're going to do a lot more like subtracting, adding, multiplying, dividing negative numbers when we get into the next section. But what is this right here? If you have 3, take away 6, where are you going? Yeah, you're going back, right? Here's 0. You're at 3, but you got to go back 6. So you're going to land back here at -3. So that would be a -3 inside the parentheses. But But then what does the absolute value turn around and do to that number? It turns it positive. And what's the operation here if there's no other operation written down? Yeah, it's multiplication. So that absolute value is actually going to take that negative 3 and turn it into a positive 3. So you do what's inside the absolute value first, then you actually apply the absolute value at the end. So notice it's not like the absolute value doesn't turn this into addition or anything like that. All it does is it says take care of whatever's in there first, and then at the end I'm going to come behind and turn it positive. Then we can just finish it off. So what should come next here? Got to be the multiplication because that comes before addition, and then it looks like here would be like something like 11. Okay. We're not going to necessarily deal with absolute values a ton in this class, but if you take Math 60 after this, you will do more with absolute values, so we just kind of introduce them just in case you might run into them in your next math class. But within these, I'll give you a couple. I think there's a couple on the quiz too for 3.1 that there might be some absolute value stuff in there. Okay. All right. Do you guys have any questions about absolute value in general or negative numbers or the number line? Okay, so I got just a little practice thing here for you guys to try out some basics about negative positives. Tomorrow, if you stick around, we can go through some of these answers at the end. But then tomorrow we're going to get into more of the actual operating with negatives and positives, just because there's some different rules for addition and subtraction versus multiplication and division, and that's kind of what we're up to. If you haven't finished that second quiz from chapter 2, the one we were just looking at, then make sure you get that done tonight, because it's due. And on these worksheets, I don't collect them. I don't mind if you work in groups, and you don't have to necessarily do them in class if you don't want. If some of this stuff seems like still in view, you don't have to stick around and wait for the answers, but I usually try to get through them if I can at the end of class. So you're more than welcome to stick around and work on them. Let me know if you have any questions, and I'll give you guys maybe, I don't know, 10 minutes, 15. See where you're at in 10 minutes. Kind of show you how to get through these. Let me see what we got. You guys can't see what I'm doing now. So just when we're initially plotting on that line, right? So the first ones I had you plot were so here's 0. Okay, then what was it? So 1 went up to 3. So you put maybe a dot at 3. The other one went back 2. So then that would be back here at -2. Then I gave you a couple other ones to plot. So 1 would be just there. Let's see, 3, 4, 5, 6, 7, is up here. And you could just add your own labels. -2, -3, -4, -5 would be there. And then -3 would be right there. Yeah? Okay? So I might refer back. I usually just introduce the number line. It's sometimes when you get into adding and subtracting negative numbers, it helps to visualize on the number line, so I might pull one up every once in a while. Then with the absolute value, well, if you start with the absolute value of 5, what's going to happen? It's just going to be, stays positive, because that's what the absolute value does. If you try to take the absolute value of -3, what's it going to be? Just positive 3, because it just takes negative numbers, turns them positive. What's the absolute value? 0. It's just 0. 0 has no sign. It's neither positive nor negative. And also the distance from 0 is 0. So that makes sense. All right, then comparing 5 and -2, which way do you go? 5 is greater than -2. And going the other way, we got -8 compared to 1. Which one's bigger? 1 is bigger than negative 8 because it's further along the number line. I'd rather have $1 than minus $8. All right. Then within the order of operations, I had this 5 times the absolute value of negative 5. So what should we do first here? We need to switch that, yeah. So that needs to become what? Positive 5. So the solution here would be positive 25. Okay. Then in the next one, I got what? I got 15 minus the absolute value of 3 times 8 minus 5. So what happens when you have parentheses inside of parentheses? You just got to go inside first. Okay, so we got to go we have to take care of that first. So then that would be 15 minus the absolute value of 3 times 8 minus 5 is 3. So then inside 3 times 3 is 9. And what's the absolute value of 9? Now, it's another thing that's really common is that people, when they see minus an absolute value, they'll want to turn this into addition because they're thinking it's going to flip that number positive. But that's not how it works. It's just going to take care of the number inside of it. It's not going to mess at all with the signs outside. So that sign isn't going to change. It's going to stay subtraction, and this 9 is going to stay positive 9, but then it's going to get subtracted from 15. And so the answer here is what, 6? 15 minus 9 is 6. Okay? All right. Questions on any of those? You guys feel pretty good about that? All right. Then the last one, and this is kind of getting into some of the weird rules that happen when you have negative and positive numbers. So what I told you is that the lowest temperature was what? Negative 90. And the highest temperature was, where'd it go? 58. Right? So those are a negative and positive number. Now my question was, so first write them both as integers. Okay, so I mentioned in this worksheet up there, I forgot to mention it in class, but the negatives and positives, the whole numbers together, those make up the class of numbers called the integers. So those would be the integers. Now, my other question was, what's the difference, though, between those two numbers? So what is the difference?
We kind of got 2 answers.
Okay. What were your 2 answers?
Well, the first time was 32 because we did the absolute value
Okay.
version. And then, but like logically thinking about it, it was 148 because that's, I don't know.
So logically thinking about it, I think you're right. The logically thinking about it is probably the right way because it can't be 32, right?
No.
It can't be 32 apart because like this is already 58 above 0. You got to go 58 degrees just to get back to 0. And then you got to keep going, right? So the logically, and the reason why is because we're dealing on a scale here that goes, on both sides of 0. So 58 sits here, and negative 90 sits there. And my question is, well, what's the difference? In other words, how far apart is it, between the two temperatures? Well, if you're down at negative 90, just to get to 0, how far do you have to go? 90 just to get back to here. And then you got to go another 58 to get back to the very top. So logically, what's the answer here? It's 90 and 58 put together, which is what? 148. I think that's the right answer. Okay, it's 148 degrees apart. Now the question is, what does difference usually mean? Difference usually means subtraction, right? So thinking about it that way, and this is probably where you got your other answer, right? You said you did some subtraction. Because typically difference is equal to minus. And so then you say, okay, well, what is 58 minus negative 90? Well, it turns out that the answer is 148. And so then what happens is we have some sort of weird rules with negative numbers because of the way that the operations work. Like we know logically the answer has to be 148. So then what that's telling us is that when you subtract a negative number, then in essence, what are you really doing? What you're really doing is subtracting a negative number turns into addition, apparently. And that's actually true. And so the answer here is 148. And we'll work more with that in the next section. I didn't bring that today, so we'll just do that tomorrow. But that's kind of the idea, is that we just have to recognize that when you deal with negative numbers, goofy things can happen. And so we're going to have to introduce some rules with them, just so that goofy stuff doesn't happen. So, okay? Any questions about that one? You can see in the picture, right, why it has to be 148? Yeah. Okay. And then we'll talk more about the rules tomorrow. So that's all I got for you today, though. Don't forget your quiz today, if you haven't done it.